safe. What it does is reacts with these two things. You're doing net ionic equation. We start with cadmium. You make this. You say, what good is that? And I'm going to tell you this because when you come up and ask me this question when you're doing your unknown, I'm going to say, I don't know what I was talking about. Look back in your notes. He also says it in the paragraph underneath there. This is a deep red-brown. This is a pale yellow to white. I'll just say white, because that's what most people see. So notice, if you do this test and you only get a white color, what's the conclusion? Your sample had cadmium. If it has any reddish color to it all, it had copper. Now the question is, what's the amount? Notice here you're going to have medium amounts of these, and these are both big precipitates, by the way. In other words, they're bulky, so even a medium amount gives you a fairly large looking amount of precipitate. So these are fairly large, but if they're equal amounts, it's going to look really dark red. If you have a trace of this and a medium of this, it's still going to look fairly red. If you have a trace of this and a principal of cadmium, it's still going to look pink. Okay, so the intensity of color, if you have a lot of precipitate, will tell you possibly some information about the proportions. But the other part here is the test for cadmium over here. Okay, so this is just our copper test. And what happens is you produce both of these precipitates. When you're doing your unknown, if you have no copper and you haven't seen any blue, when you do this, you should only get a white precipitate, plus any contaminants that might carry on. And to try to estimate your amount, as I said, you go by the volume of the precipitate and the intensity of the red-brown color. You have a really big amount of precipitate, and it's really deep red-brown, same as your original, then maybe you have a principal of both of them. So those are the things you have to consider there. But we're also going to do the test for cadmium separately. So these are your two precipitates. And you save that as your confirmatory test. Now the next part, for the other half of the solution, it still has a large excess of ammonia. And now you're going to need the potassium cyanide. Okay, so I went through procedure 10A. Okay. 10B, it says, part 1, if copper is absent, you don't need potassium cyanide. Now your known has copper, so you will need potassium cyanide. You get potassium cyanide at the stockroom, and I'm going to expect you to know what you're doing. Okay? To get the potassium cyanide, this is this original half here, so it's this sample. I should have just said sample because I said you could buy it. And about 3 or 4 drops of 15 molar ammonia in a second test tube. It's not critical, you just have to have it basic. This is your waste tube. And I want you to bring both tubes so I know that you have a waste tube ready to go. Okay? I don't trust you to say, oh, I have it back there in my locker. I want to see it. That way when you bring it up to me, you're sure to have it. You go back and use it when you get to your locker. So this is what you bring to the stockroom. I add KCN. And what I do, this is going to be a blue color. First thing I do is check to make sure this solution is basic. I have a bunch of strips of red litmus, and if you ever want to know what you use to test for base, you look in my stockroom window, you see strips of red litmus, you know that must be the litmus color you use for base if you haven't figured it out already by testing it yourself or remembering it from last semester. So what I do is hold this test tube near my red litmus. And if it doesn't turn blue, the first thing I'm going to ask you to do is go back and add some more 15 molar ammonia. Notice I do this thing after our exams and everything, and I'm still here because I don't take any chances with it. I make sure it's basic before I add cyanide. I'm the one that's closest to it when I add the cyanide. Right? So don't try to poison me because it won't work. Okay, so coming back to that, I check it. If it's not basic enough, I will ask you to add more ammonia, so you do that. So you go back and add some more 15 molar ammonia. And lots of times what people do is they mix up this instruction with this one. They're not doing it intentionally. They just say, oh, I'm supposed to add acetic acid. And now they're giving me a test tube that's been acidified. And as soon as you add KCN to acid, it makes HCN gas. You smell almonds for a few seconds and say, oh, that smells really nice. It's curing my cancer. Whatever they say about almonds. Anyhow, it cures a lot of things. So anyhow, like I said, I don't poison myself. We've never poisoned anybody with it. But we do dispose of the waste properly. That's why I have you do the waste test tube, because you turn all your washings and things back to me after this procedure. We don't really make enough to poison a bunch of fish, but we always want to be environmentally conscious, so we collect everything and dispose of it properly. When I did this in undergraduate school, we had 300 or 400 people doing the experiment, and everybody was doing what I don't know if it still says flush the waste down the drain. Oh, here it says in the manner described by your instructor. The old book said flush it down the drain with lots of water. And that's what we used to do. And our rivers mostly didn't have fish in them. But that was not from us, but it's from, but nowadays we do take proper care with it. Speaking of KCN, you may read about this from time to time in the newspaper. It's used a lot when you're purifying gold. And they keep finding these gold dealers in Los Angeles and different places where they use 4 or 5 pounds of KCN. And what do they do with it? They flush
dump it down
the drain, and then EPA comes looking for them. Eventually they find them and charge them more than they ever made from the gold, unless they take their gold away. Okay, so it is hazardous. We do have to be careful with it, and we do dispose of it properly. What I do is I have a basic solution that converts it to cyanate ion, which is now on this. So I collect it, I dispose of it, and treat it properly. So what you're doing, I add the KCN. After I'm sure that your solution is basic enough. You add and I'll come back to the equations in just a minute, but when you add the ammonium sulfide, what you get is you add a KCN, so it converts cadmium to this complex ion. You're adding ammonium sulfide. It's a basic solution. You have lots of ammonia in there. You make this yellow precipitate again. Unfortunately, it's easily contaminated. If you didn't get rid of all your ions along this way here, you usually get, instead of something a bright yellow, you get something brownish yellow. That's the lead, the mercury and things, all those little residues sort of try to overpower the yellow color from the cadmium salt. That's your confirmatory test.
Is that the one that you said was like a pale yellow?
Which one?
The
no. The pale yellow was that complex ion. I was just looking at my equation because something's not quite balanced here. minus, 3 minus, and I get, oh yeah, I got it's balanced. I was looking at the wrong thing. Okay, it's balanced. So this is your net ionic equation, and the pale yellow thing was the tetrachloromercury ion last time you can see. So, okay. So what you're going to do, you add the NH4S, centrifuge, decant into the waste tube. You wash, you put a drop of 15 molar, 2 drops, it's not critical, you just want to make sure it's basic. So you wash the precipitate with water and 15 molar ammonia. About 4 or 5 drops, 2 or 3 drops of the 15 molar ammonia, 4 or 5 drops of water. That goes into the waste. Centrifuge decant into the waste. And you want to store with water, it probably has enough excess ammonia because by now we've gotten rid of all the cyanides. That's your confirmatory test for cadmium. And you bring the waste test tube to me immediately. I do not issue cyanide after about, let's see, the period ends at 1:15. So about 20 after 12 or thereabouts, I'll say last call for cyanide. It's not for you to poison yourself, it's for you to do the test. And that gives you enough time to run through the test and get the waste back to me. I don't want you to end the period and put the waste somewhere in your locker where you don't, in your test tube rack, and then you come back and you start washing test tubes and flushing the waste down the drain. So I don't start you too late with the cyanide, and I write your name down. This is where I start really learning the names. Eventually I'll learn everybody's names, and sometimes I'll even pronounce them correctly, but that's another thing. And I look for you before you leave so that I can put the cyanide or dispose of the cyanide properly. That's one of the things you say. What happens to the copper